The Alcubierre Drive is a concept that proposes faster-than-light travel by manipulating space around a spacecraft using a negative energy density field. The idea was introduced in 1994 by Miguel Alcubierre based on solutions to Einstein's field equations, and it involves creating a warp bubble in space that carries the spacecraft along. While the Alcubierre metric is consistent with Einstein's equations, it requires exotic matter or manipulation of dark energy, which may not be possible to create in reality. Some theorists propose that a theory of quantum gravity would make the Alcubierre Drive invalid. Despite these obstacles, the Alcubierre Drive remains a fascinating concept that could potentially enable interstellar travel. Although the Alcubierre Drive has long remained a hypothetical concept, Alexei Bobrick and Johnny Martiri suggest that subliminal, spherically symmetric warp drive spacetimes could potentially be constructed based on known physical principles such as positive energy. The metric associated with this spacetime has been described using the ADM formalism of general relativity. While exotic matter is required to travel faster than the speed of light, the theoretical possibility of generating and sustaining enough exotic matter to enable such travel remains impractical. Astrophysicist Jamie Farnes proposes a new theory that unifies dark energy and dark matter into a single dark fluid, with testability expected around 2030. This beautiful hypothesis relies on negatively behaving masses identical to those required for the Alcubierre Drive, and if proven correct, it would allow for faster-than-light travel, closed time-like curves, and explain the current crisis in cosmology due to a time-variable Hubble parameter. The theme of the story is the possibility of superluminal travel through the use of warp bubbles. However, this concept is met with significant challenges that require exotic matter and violate energy conditions. Despite these obstacles, some physicists propose models of dynamic warp drive spacetimes that involve the use of devices placed along the travel path programmed to operate in a pre-assigned manner. By changing the metric along the path of their outbound trip, a spaceship's crew can complete a round trip from Earth to a distant star and back in a short time as measured by clocks on Earth. Although previously unheard of and requiring prior planning and preparation, the potential for superluminal travel via warp bubbles remains a fascinating prospect. In 1999, Chris van den Broek from the Katholieke Universiteit Leuven in Belgium attempted to tackle the potential hurdles of warp drive technology. By contracting the surface area of the bubble being transported while expanding the three-dimensional volume inside, the total energy required to transport small atoms was reduced significantly. Further modifications by Sergei Krasnikov in 2003 saw the energy requirement decrease to just a few milligrams. However, despite these significant advancements, the energy densities required for the technology still remain unattainable. Physicist Harold White and his team in 2012 proposed a new method to reduce the mass energy requirements from the equivalent of Jupiter to that of Voyager 1 or less. This would involve thickening the thin wall of the warp bubble, resulting in a larger volume of energy but with lower peak energy density. However, this also means a smaller space would be available within the thickened bubble. Oscillating the intensity of the space warp over time could further decrease the energy requirement. Despite their intentions to experiment with these ideas, some, including Alcubierre, express skepticism about the feasibility. In 2021, physicist Eric Lentz described a controversial new approach to warp drives based on superluminal self-reinforcing soliton waves sourced from purely positive energy. However, other physicists argue that this concept violates various energy conditions, rendering it unfeasible. Despite the ongoing debate and skepticism, the theme of warp drive technology in the quest for faster-than-light travel continues to intrigue and fascinate scientists and the public alike. Various arguments have been put forward against the feasibility of an Alcubierre Drive, which proposes faster-than-light travel using exotic matter. Cole argues that the construction of such a drive requires an Alcubierre Drive itself, and any proposed method would face similar objections. Notario's article suggests that crew members inside the warp bubble would not be able to control the ship. Barcelo, Finazzi, and Liberati argue that the bubbles would be destabilized by Hawking radiation caused by superluminal speeds, but these problems would be absent at subluminal speeds. McMonigal, Lewis, and O'Byrne suggest that particles gathered in transit would be released in potentially destructive energetic outbursts upon deceleration. The amount of negative energy required for such propulsion is still unknown, and the practicality of straining exotic matter to a thickness close to the Planck length is questionable. Van den Broek suggests modified models that require less exotic matter but still involve curved spacetime. While closed time-like curves could theoretically be created using such drives, the chronology protection conjecture suggests that quantum effects would prevent the realization of spacetimes that allow for backwards time travel. The underlying idea of the paragraph is that attempting to use a faster-than-light travel method to build a time machine can be dangerous and lead to disastrous consequences. The term warp drive used in the Star Trek franchise describes this concept of faster-than-light travel, which originally stemmed from John W. Campbell's science fiction novel, Islands of Space. Interestingly, Alcubierre's theory of warp drive was inspired by the same term used in the show and was mentioned in his 1994 article. This idea is evident in the Star Trek tabletop RPG Star Trek Adventures that even features a USS Alcubierre.